What's up, CoderByte? Welcome back to another data structures and algorithms video. I'm Elizabeth, and today we are going to be doing our last cyclic sort pattern problem. Say that 10 times fast. I'm here sweating up a storm. I hope everybody is having a good summer so far. This problem confused me at first when I prepped it, so I hope that I can break it down for you all step by step and we can do this together. Let's get into it. Okay, as usual, we are going to just go over what the cyclic sort pattern is, what it's useful for, why we use it, that sort of thing, just as a review in case you haven't seen our last couple of videos on this topic. So cyclic sort, what is it? This pattern is best used for problems involving arrays containing numbers in a given range. Now that is a super important piece of information. We're looking for problems where there are arrays of numbers that are in a range, let's say from 0 to n or from 1 to n. The reason for that being that we're going to use the indexing of the array as kind of our guideline for where those numbers belong in the array. And if it weren't numbers in a given range, we wouldn't quite be able to use the indexing of the array to do a sort in the same way. This is, this aspect of the problem is what allows us to do the cyclic sort in this way. So that's a really key point here. Often this pattern is useful for determining what order the numbers should be in, missing numbers, duplicate numbers, etc. Using this pattern, we can do all of the above with a maximum time complexity of a big O of n. So that's linear time, which is really, really valuable when you're doing any sort of sorting. Also, often these problems will ask you to do the sort, or not ask you to do the sort, but ask you to solve the problem in place, meaning not using any other data structures, not generating any other space complexity, but rather only using the array passed in. Okay, so with all of that information, what's this week's problem? So this week's problem, which I would categorize as a hard cyclic sort problem, given an unsorted array containing both positive and negative numbers, find the smallest missing positive number in it. You should do this in place with a maximum time complexity of a big O of n. So an unsorted array containing both positive and negative numbers. There's our wrench in our general, how we normally do a cyclic sort, because our negative numbers don't correspond to any index in the array to place them at. So you'll see how we're going to deal with that in a second. But first, let's look at a sample input. So here's our sample input. You can see we have the numbers, the positive numbers 1, 2, and 3, and then the 0 and the negative 2 are thrown in there as our wrenches, right? So how are we going to deal with that? So because we already have the numbers 1, 2, and 3, our missing number in our range is actually going to be 4. Because we know we have one missing number and we have all the numbers between 1 and 3. So our missing number will be 4. How do we get there? So what's our approach basically? So the first thing we're going to do is perform a cyclic sort. However, because we now have these negative numbers thrown in, what we're going to do is we're only going to place a number if it's positive. So what that allows us to do is we're going to put all of the positive numbers in their correct places in the array. And what that will do is bubble the negative numbers and also 0 into the spots that are basically representing the missing number, the missing positive number. So because we're able to do the cyclic sort just on the positive numbers, we can then loop through the array after we've sorted all of the positive numbers. And the index of the first number in the wrong place will indicate which number is missing. So in case you didn't quite understand that, let's go through an example and walk through it. And you'll see kind of how this is, again, actually a pretty simple problem if you know just to do the cyclic sort on the positive numbers. So let's watch this in action. So here's our input from the previous slide, and here are our indices, which you see we have an array, and we have indexes 0 to 4. So we're just going to walk through and do our regular old cyclic sort. And remember that this is a 0-based indexed array. So that means that, let's say, our first input, 3, won't actually, I don't know why that arrow is doing that, but I'm going to leave it in, and you guys will forgive the editing on this. We'll see if it fixes itself. But we're not going to put 3 in the third spot in the array. We're actually going to put it in the second spot, again, because this is a zero-based indexed array. Zero-based indexed array. I don't know. Leave it in the comments. Sometimes I say the wrong thing. So what do? We take a look at 3. We look at what's in the spot that we want to swap it with, right? So that will be, and we have our orange arrow back. We're good, people. That will be that -2. So we'll swap it, right? And -2 is not positive. So we're not going to continue to deal with that index. We're going to move on. 0 is also not positive. So we're actually also not going to be sorting that 0 in this case. 3 is in the right spot, so we're going to skip over it. 1 is not in the right spot, so we're going to swap it with what's in its place, which is -2. So we're going to swap that like that. And now we have a negative number again, so we're going to ignore it. And we're going to move on to that 2. 2 is not in the right place. It belongs in that first index, so we are going to swap it with 0. So now we're left with a sorted array, meaning that we haven't sorted any of the negatives and we haven't sorted the zeros. But when we loop through this array, the first number that is in the wrong place will be this -2. That doesn't belong there. So we know right away that the number we're missing will be 3 plus 1 because this is a zero-based index. Zero-based index array. So that's kind of how this problem works. I think with more inputs and outputs, maybe walking through the code with a debugger, this will become, super clear. But it's basically pretty straightforward once you know that little catch that we're only sorting positive numbers. Let's code this out. Okay, so I'm in Visual Studio Code as usual with a totally blank file. And I think, as per usual, I'm just going to define our function. And we're going to say that this is called find the smallest missing positive number. And it's going to take an array of nums. And then let's define our test cases down here. So let's say console.log, and I'm just going to copy this from the slides. So in this case, we're expecting that we're going to return 4. And then let's see, I have a few other test cases with some extra negative numbers to really, mix us up. And I think the missing number here is going to be 3. And then finally, we are going to do one with no missing numbers, no negative numbers, just to make sure that this works even without the negative numbers. So here we're expecting to return 4 because we're missing 4 again. So I want to remind everyone this is going to look very similar to all the other problems we've done because it's basically just a cyclic sort, except we're targeting only the positive numbers here. So we're going to define our I like usual, let I equal to 0. This is essentially the orange arrow that we moved along the array from the slides. And I think I'm going to put the array length in a variable as well because I know we're going to use that later on and you'll see why. So let's say the R length is nums.length. Nope. Why are you doing that? Okay, and then we'll call it a day. So how does that work? Okay, so I don't know what's going on today. All right, back to our regularly scheduled programming. No pun intended. Okay, so let's make our while loop, which we're basically going to go through the array until I is at the end of it. So that's going to be while I is less than the array length, right? And we're going to basically kind of capture what are we looking at, what do we want to swap it with, that sort of thing. So let's say our const to swap is going to be nums at I. Right, so wherever we are in the array, that's what we're trying to swap. We want to put it in its right place. And then the swap with index, which is where we want it to go, will be, let's say, here I can do a comma here and say swap with index, where we want it to go, is going to be the number that we're looking at minus 1, right? So let's say we're looking at 3. This needs to go in the second index. So we're going to say that it's the actual number minus 1. And again, that's because we're dealing with a zero-based indexed array, and we're not sorting that 0. That's an important piece here. We're ignoring the 0. If we weren't ignoring the 0, we wouldn't necessarily have to subtract 1, because we could put 0 in the 0th spot and everything else would fall into place. But we're not sorting the 0. And the reason we're not sorting the 0, by the way, is because there isn't always a 0 in each input. So we want this to work for every single one of these test cases. And in that case, we want to actually only sort from number 1, right? So we have those things defined. And essentially what we want to do is we want to determine, do we want to actually move this number? Now, what did I say? We only want to move this number if it's positive. So if toSwap is greater than 0 and toSwap is less than or equal to the array length, and this is why we captured that nums.length above, because we're using it multiple times in our while loop condition and also here. So we want to make sure that we're only placing numbers that have a place in this array at all. And we also want to make sure that it's not already in its right place, right? So toSwap is not equal to the nums at the swap with index, because if it's equal to where it's going, then we already know that it's sorted and we can ignore it. So that's our magic condition. This is basically the entire line that is the answer to why this question is a harder problem, is knowing when we want to actually sort. We're not sorting those negative numbers and we're not sorting that 0. So that's the line, and take some time to really understand why we need each of these cases. But basically, if we pass this, we want to swap. So this is going to look similar to everything else we've ever done. So we're going to say swap with is going to be the nums at the swap with index, right? So the thing we want to swap, the number that's already in that spot, that's going to be swap with. And that's where this number that we're looking at, toSwap, is going. And then we are basically going to say the nums at the swap with index is now equal to what we want to swap. And the num where we are, nums at I, is now equal to whatever we kicked out of its place. So that's that swap with. And then the only other thing to do is iterate if this line is falsy, right? So if that's not true, we want to just iterate and say I plus equal to 1, right? Move along, right? So let's see what we get. Let's see if we return the nums at the end of this, right? What do we get? So let's look at our test cases here, and let's say node code. Okay, so here we get exactly what we saw in the slides, that we have all of our positive numbers sorted, and the first number that doesn't make any sense, the one that doesn't belong where it is that -2, which is at the 3rd index in this array, meaning that we're missing our 4th number. Here we have our next case, right? And here all of the numbers are in their right place, 1, 2, 4, and 5. The first number that's in its wrong place is this -8, which is in the 2nd index, indicating that we're missing a 3. So that checks out. And then the same thing with this array. We have 1, 2, 3, and 5. Now we'd actually only cyclic sorted 1, 2, and 3. Why is that? Because 5 is outside of the bounds of this array. This array has a length of 4, and 5 is outside of it. So 5 is actually the first number in the wrong place, indicating that we are missing whatever should be at the 3rd index, which would be 4. So I hope that's clear to everybody. Again, I highly suggest that you go through this with pen and paper, a debugger, however you normally do this, so you can watch the swapping happen. But basically, because we're doing what we're doing, I like to use the word bubble, because that's how I'm imagining this in my mind. But the numbers that don't belong, that aren't actually being sorted, bubble, they fall into the places that are missing, the missing numbers, essentially. And then the rest of the negative numbers or the zeros kind of just go to the end of the array. So that's basically it. All we now have to do is loop over this array and return wherever we find that number out of place. So let's do that right here. So I think I'm just going to do a regular for loop for I is equal to, or maybe I'll use j because we already have an I. So j is equal to 0, j is less than the array length, j plus plus. And we can say that if nums at j is not equal to to j plus 1, so if whatever the number is at that spot is not equal to the index it's at plus 1, we return j plus 1 because that's the number that we're missing. And that's the entire problem. The last piece of this is that if it runs through and there are no numbers out of place, we are just going to return the array length plus 1. Because let's say I don't know if this would actually happen because the problem specifically says it gives you a range of numbers and there's going to be one missing. But let's say we get a fine smallest number and we just get, let's say 4, 3, 2, and 1. Our missing number here would be 5. But actually, yeah, we totally could get this. And that would mean that we'd be able to sort each of these. And this would never happen because each of these numbers, I'm going to comment this out for a second, and we're just going to return nums and see what that looks like. So each of those numbers is in its correct place. So that means we're missing a 5. So we know that we're missing a 5, and we can just return the length of the array plus 1 because we already have all the numbers that fit in their places, and the missing number is just the next number in the list. I hope that's clear to everybody. Comment that out, take that out, and let's run this and see what we get. So we get 4, 3, 4, and 5. So we got what we set out for. So again, it looks almost exactly the same as all of the other problems we did. And I really suggest that you kind of compare and contrast all of the other code from the other cyclic sort problems that we've done together, because so much of this is the similar problem or similar pattern. And that's the whole point of this series, that all problems in a certain pattern will follow similar rules. They'll have similar scaffolding. And then there are going to be these kind of gotchas that you have to know about or think of on the fly in an interview, because I know you all can, and kind of just to kind of mess with the pattern, the underlying pattern slightly. That's what I got for you guys this week. I'll see you in the next one. All right, and that concludes our kind of summary of the cyclic sort pattern. I hope you all enjoyed this one. I certainly did. I was a little bit more unfamiliar with this pattern as opposed to all the other patterns we've done, and I really learned a lot. So I hope you all did as well. Join us next time. We'll be starting a brand new pattern, which is really exciting. And I hope everyone is having a great week. See you all next time. Bye.